Hello and welcome to my video, lesson 7.2 on solving logarithms. Alright, so just to start off here, I just want to remind you guys that logarithms based off of 7.1 have the base down here, they have the answer up here, and that equals the exponent. So basically what that means is that we have a base, right? We have an exponent, and that equals the answer. That's a normal exponential function. So with a logarithm, it's kind of flipped. This is the way to get the exponent by itself and solve for the exponent. So, for example, if we look at log 1, and just a reminder that it's base 10 if it doesn't say otherwise. So log 1, so log base 10 of equals 1 equals 0. So the answer is 1, the exponent is 0. So if we look at these ones here, which I'm going to right now change it so you guys can read it a little bit more clearly. My bad. Anyway, so if we look at this, the exponent is the 0, and the 1 is the answer. So based off of this, based off this, based off this. So hopefully you can see how that's based off of. Let's take a look at logs of some of these weird numbers and make just a quick estimate of what those equal. Well, if we have base 10, we have an exponent, and it equals 134, we can't actually solve for this directly, but we can say that it's close to 100 and much further from 1,000, right? So if x was 2, it'd be 100. If x was 3, it'd be 1,000. So it's much closer to the 2, and so I'm going to say 2.1. I have no idea if that's correct. We can check it after, but somewhere in there, right? Closer to the 2 than the 3. Okay, the other one, again, log of 9,872. So this is like saying 10 to the x of 9,872. So we can say that it's close to, if we had 1, 2, 3, 4, so 10 to the 4, and it is further from if we had 10 to the 3. So we can say that it's 3.9, somewhere in that range, right? I don't know exactly, but somewhere. So let's just try this out and see if we can get the answers roughly close to where we had put them before. So let's see. Ooh, pretty close, 2.09899, so pretty close to 2.1. Let's try the other one, log 9872. I'm guessing it's going to be like 999 or something. 994, okay, so you know, it rounds up to 4.0, but close enough, close enough. Okay, so what about solving some of these questions? What can we do here? Well, we can solve them through the same method. So 5, so those were estimates if we can't get the exact answer. But 5 to the x equals 125. So 5 to the 3 equals 125. So x equals 3. So our answer is 3. Okay, same thing over here. Let's go through it. So 3 to the x equals 81. Right? So 3 to the... Okay, actually, I'm going to pretend like I don't know this answer and go through it as if I didn't know it. So what would we do if we didn't know the answer very quickly? We would take our number, 81, divide by 3, we would get 27. We would divide by 3 again, and we would get 9. Divide by 3 again, and we get 3. So 1, 2, 3, 4 3s. So what we can say is that 3 to the 4 equals 81. So x equals 4. So our answer is finally 4. You can do the same thing with the other question. I saw it right away, so I apologize if I went too quickly. So 125 divided by 5 equals 25, divided by 5 equals 5. And so we can count up the number of 5s there are, 1, 2, 3. So that's how we got that 3, and therefore this 3. All right, so those are the basic questions when they're relatively easy to do. What can we do next? In our calculators, the default is always base 10. If we want to change the base, well, then we can use the formula given here. So we want to change the base sometimes. Why is that? Because our calculators, this is the key. This is why we use changing base most of the time. So our calculators only have log base 10. It doesn't tell us, it just has a blank, right? But we know that we just assume it's base 10 if it doesn't say. So this is just a general form showing that we can change to any base, but in our calculator, and most of the time we're using base 10. Okay, so use your calculator to estimate the following to the nearest hundredth. If you can, pause the video and try these questions out. That'd be great. And now we will try them ourselves. So what we're going to do is use the rule that, or the formula given right here. So log of b, and the b value is 340 here, divided by log of the base, which is a, which is the 6 here. And we can calculate that in our calculator. We're going to do the same thing for the other one, log of 297 over log of 4. Okay, and so now what can we do? Well, let's try getting those answers. Log 340, make sure you finish the brackets, divided by log of 6, 3.25. We're going to go with that. Let's try it again. Log of 297, finish the brackets, divided by log of 4. Enter, so 4.11. It's because it says to the nearest hundredth. That's where we're rounding. And hopefully those helped you out a little bit, getting used to that. So yeah, the only other thing to say is that there are potentially word problems, and we'll get into at least one of those in the next few videos. But decibels, Richter scale, pH are all things that are measured with logarithmic scales. So anything that has a logarithmic scale could be used as a word problem. They also will take an exponential scale question and force you to solve it with logs. So if it has a logarithmic scale, or if it has an exponential scale, they can still actually force you to do logs with it in a word problem. All right, I hope this video helps you understand solving logs a little bit better, and good luck.